Hello learners, welcome to Phychemath with Mr. Rhema, and in this video I have selected some certain questions under unit and measurement or physics subject that we're going to be pointing searchlights to. Alright, now let's dive in. Now the first question here says, if a sphere of radius r moving with a velocity v under streamline conditions in a viscous fluid experiences a retarding force F given by F is equals to KRV, where K is a constant. Derive the SI units of K in terms of the base units. Now, what do you understand by base unit? Base unit simply refers to fundamental units, that is, the units upon which other units depend on. Alright, so the first thing we need to do is to write out what we were given. What were you given? F is equals to KRV. F is equals to KRV. Alright, then the next thing to do after writing this out, since we were to make K, we were to derive the SI unit of K in terms of the base unit, then the first thing you need to do here now is to make A the subject of the formula. And how do you do that? You divide both sides by the coefficient of K. Coefficient of K refers to every other element beside K, which is RV. So you divide both sides by RV. Alright, so R will cancel R, V will cancel V. Then you are left with K is equals to F over RV. Alright, now having made K the subject of the formula, then the next thing is, what does each of these parameters, what do they stand for? F stands for force, and force is mass times acceleration. The formula for force is mass times acceleration, and you have R, which is your radius, and V, which is your velocity. Alright, now the next thing is, having spelled out the formula of each of the parameters, then the next thing is to represent them in terms of the units. Alright, so K is equals to, we have mass times acceleration. Mass, the unit of mass, which is a fundamental quantity, is kilogram. The unit of mass is kilogram. While the unit of acceleration is velocity, change in velocity over time. Positive change, actually, that is increase in velocity over time. So, and its own unit is meter per second square. Meter per second square. So everything over radius, the unit of radius is meter, while the unit of velocity is displacement over time, displacement per unit time, and the unit of velocity is simply meter per second. meter per second. Now, having spelled all this out like this, then the next thing to do is to divide. Then what we need to do is we say K is equals to kilogram. If you multiply the numerator together, you have kilogram meter over s square. That is for the parameters that are in the numerator, that is the unit of mass and the unit of acceleration. Alright, then this division sign over, then we multiply the numerator for the parameters that are below. You multiply the numerator, which will give you m square over s. Then all you need to do next is you divide, and this will implies that K is equals to kilogram meter over s square times, of course, you know that when the division sign change to multiplication, then the fraction that are below will be inverted. That is, the denominator will become the numerator, while the numerator will become the denominator. Therefore, you have s over m square. And so what that means is that K is equals to kilogram meter over s times s times s over m times m, which means m, one of these m will cancel one of the m here, one of the s here will cancel one of the s here. This implies that K is equals to kilogram over, then at the denominator you have m left here and s left here, which will give you m times s. So you have ms. So this implies that K is equals to kilogram per meter per second, kilogram per meter per second, and that is our SI unit. Or you can also write it like this: K is equals to kilogram per meter per second. You can express it like this, and you can also express it like this. So that is our K in terms of base unit. You can observe that all our units are in base unit. Kilogram is a base unit, meter is a base unit, and S is a base unit. So that is what it means to derive the SI unit of K in terms of the base units. So you must remember that from the question that says K is equals to F, from our derivation that says K is equals to F over RV, mass times acceleration, which represent force, we could have said F, the unit of force, is Newton. Meanwhile, that will be the SI unit of force, but not the base unit of force. So since the question requested that we should find the base units, and that is why we follow this pattern and we arrive at this final answer. Now to the second question, which says what are the SI units of K, so that the equation velocity is equals to K times density is dimensionally correct. give your answer in terms of the basic unit. Again, the instruction is it should be in base units, basic units, which is also referred to as fundamental units. And now you have velocity is equals to K times density. So density is mass over volume, so which means velocity is equals to K times mass over volume. Alright, so this implies that if I want to represent all these in terms of their first letter, I will say V is equals to Km over V over volume. Let me represent this one with VO. So this implies that V multiplied by VO is equals to Km. Then, just like we did in the first question, divide both sides by M. So M will cancel M. M will cancel M, so that you will have K equals to V times V naught over M. So K is equals to, what is our V? Our V is velocity. And of course, from our first question, you should know the unit of velocity, the base unit of velocity, and of course, volume. You should know the unit of volume. And then here is mass. From our first question, you should know the unit of mass. And so I will leave you with this to complete it and drop it in the comment section, your final answer of your derivation of the SI unit of K. So till we meet in the next class, bye for now.